Good afternoon, everybody. I would like to welcome you to this co-hosted webinar between Ibex and Philips. And I'm very happy to be introducing some real pioneers in the field of both digital pathology and artificial intelligence to bring us their real life accounts of routine clinical practice with AI, ranging from quality control to primary diagnosis. A few housekeeping elements. Very happy to take questions. We will have Q&A at the end. Please enter these via the Q&A entry, not via the chat. We will be looking at the Q&A chat, and we'll take the questions from there. Joining me today as your presenters, the majority of the presentation will come from Doctors Judith Sandbank and Dr. Delphine Raoux, both pathologists, real experience now in digital and AI, as mentioned. And supporting a quick introduction is going to be Kieran Malvia, the Director of Business Development at Philips, and then myself, Stuart Shand, the Chief Commercial Officer at Ibex. The opportunity of what digital pathology and AI is bringing us is allowing pathology to transform in a completely different way than it's ever been able to do before. Labs and networks are able to drive real scaled growth. And they're able to do this at the same time as bringing standardization. On top of this, the combination of digital pathology and artificial intelligence is driving real productivity. And at the same time as driving productivity is reducing and almost eliminating diagnostic errors. And this is not something of the future. This is something that is really there today. Pathologists working with digital images supported by AI as part of their everyday work. As a company, this is what Ibex focuses on. We focus on clinical grade AI, and we use our AI to be able to support the pathology workflow, to drive improvements in accuracy and efficiency. And at Ibex, we do this by bringing insight, Ibex Insight, as I call it, the ability for our algorithm to go beyond the detection of cancer, but bringing in the capabilities of identifying many other clinical features to be able to support the pathologist to the utmost, driving those accuracy and efficiency numbers to the highest possible levels. Today, we are deployed across the world. We have many sites up and running now. We work with the industry to be able to bring artificial intelligence in a very open way into the pathology workflow, and incredibly proud of what we have achieved so far. Some examples of customers who are already implementing this in a routine way. Core Plus, top left, the first lab in the US to implement AI in a routine clinical setting. Path, the first in the UK to do the same. And then Medipath and Maccabi, from which we will hear directly today. Medipath having deployed AI now network-wide, working with both prostate and breast, as well as Maccabi, the first lab in the world to implement AI in a routine clinical setting, and now gone way beyond simple AI QC in both prostate and breast, but are well on the way towards a journey of fully digitizing their pathology lab. Clinical grade AI means we need to validate, and here a number of studies that have been performed with select partners around the world, showing that both across prostate and breast, the performance of the algorithm is delivering exceptionally high AUC, or area under the curve, a measurement of accuracy of the algorithm, very high levels of sensitivity and specificity, the studies performed on large numbers of slides and cases, and some very powerful numbers that have come from this, of which we will see today, improving reporting efficiency by 27%, driving productivity gains by 37%, and reducing errors by up to 12%. As well as in Europe, we have also worked in the US. We published a paper together with UPMC in the Lancet last year. And here, the measurements that you see from the Ibex technology goes beyond that cancer detection, being able to use AI to support in the grading of cancer, as well as identifying these more rare and difficult to find clinical events such as perineural invasion, high-grade PIN as an example, in addition to being able to characterize the cancer by bringing in measurements. The solutions that we have, highly validated, they have CE IVD marks and are ready yet to be deployed in labs worldwide. When we talk about insight, we are able to visualize that insight on the screen for pathologists in the form of heat maps. The top 3 images showing how we can detect not only adenocarcinoma in prostate, but using our Gleason heat map that you see to the right, support pathologists in differentiating between grade 3, grade 4, and grade 5. At the bottom, you see examples of using AI to quickly identify perineural invasion, high-grade PIN, and going beyond this to identify the other characteristics important in prostate, such as atrophy, inflammation, blood vessels. And our algorithm is even intelligent enough to differentiate between benign glands and large intestine, often appearing on a slide as an artifact. We go beyond prostate to breast. We have many different examples of our AI's capability to differentiate between the various different subtypes, and even going beyond this to detect DCIS. And in the same way as we did in prostate, in breast, we can support in the grading here, differentiating between blue, where it would be a low-grade DCIS, and red, which would be an example of high-grade DCIS. Again, supporting pathologists in identifying these more difficult areas to find, angiolymphatic involvement, tumor-infiltrating lymphocytes, the power of AI really being very clear. To summarize, AI is delivering in 4 main pillars. Our customers today are seeing improved quality in their labs, this quality being driven by insights being able to go beyond cancer detection to identify more, to be able to support the pathologists more. And when you combine these capabilities, it's clear how the efficiency gains come, and we're going to hear about that today, not only in terms of reporting time, but also in terms of improved turnaround times. And this combined leads to improved levels of confidence for the pathologists, for the patients, for the management of the labs. To be able to deploy AI, we of course need to work with the digital pathology providers. And I'm very happy today to be joined by Kieran, who is going to talk to us about the open platform for pathology that they have at Philips. So Kieran, I hand over to you.
Good morning, good afternoon, and good evening to all of you joining from across the globe today. Thanks a lot, Stu, for setting the stage. And it's a pleasure to share this platform with you today to celebrate the milestone for the journey of digital pathology. You know, I salute to the visionaries who back in 2000s dared to believe that the digital change in pathology was possible. And look at us. In mere 15 years, the world of oncology has become so complex, yet so open for innovation. I would not talk today about the advantages of going digital in a pathology lab, but I would like to talk about a combined vision that we saw with the clinicians towards driving diagnostic excellence with an efficient workflow, combining the power of AI in precision medicine. At Philips, the innovators think about ways to help the healthcare transform and perform along these four quadruple aims mainly. It looks simple and intuitive, but it is the basis for all the technical innovations in Philips. Digital pathology solutions improve patient experience and deliver better outcomes by reducing the time, but also coupled with AI, ensure better and precise diagnosis. Care providers or the staff, they are benefited by not only reduced cumbersome manual tasks, but also with a strong decision support through the use of AI. And last but not the least, as a fraternity, we are able to substantially reduce the errors, eliminate repeat tests, and reduce ill-informed decisions, all of which in turn contribute to reduced costs of care. As pioneers in digital pathology, Philips leads the market with the maximum number of fully digital clinical sites across the globe. So we heard our customers' feedback and we captured the industry trends to adapt our strategy to make our systems open. The importance of building an open platform is to be able to grow and nurture the dream of enterprise pathology. The market has now evolved enough towards maturity where the next step of interoperability can be aimed for. We all recognize that the essence of pathology platform is along three key pillars: a good image of the tissue to enable good diagnosis, a platform that can be open and scalable enough to support desired flexibility in deployment, and ability to talk across systems and networks to facilitate cross-collaboration between modalities for deeper patient insights and in turn stronger decision-making. For Philips, the first focus was always to create a good medical grade image quality. We have done this, and then the next area of focus is an open ecosystem without compromising any quality, safety, and capabilities. I speak today on behalf of all the industry partners, as this is a shared vision of the industry, and every vendor in the market today is driving towards this common goal. Having said that, there's no point in rushing towards something with a quick and easy fix, because Philips believes in addressing each element independently without confusions through the marketing jargons. Let me quickly elaborate what Philips is doing across these four pillars. To make the open image format possible, Philips has made the iSyntax format readily and freely available at the Open Pathology platform by publishing the SDK. The Philips SDK is a software development kit allowing users to interact with data stored in Philips iSyntax image format. It realizes our vision to allow the developers and researchers all over the world to work with the data natively in iSyntax format. Close to 24 vendors today have already downloaded the SDK and are now able to work with the iSyntax files freely. To create an open pathology platform, the Philips Image Management System, or the IMS, as you fondly call it, can now interact with any third-party IMS in the market, provided the third party is open enough to work on the SDK. Not only this, but the ability to automatically export anonymized images to any third-party vendor of customer's choice using the DID tool makes the adoption of AI extremely easy for the pathologists. I'll describe what DID is in a little more detail later. Not only this, but IMS is also able to ingest most common third-party image formats, and Philips is constantly working towards making the vendor-neutral, high-throughput third-party image support a reality soon. We also heard it loud and clear that with increasing confidence in AI, IMS will have to integrate these into the workflow, and Philips is committed to make this embedded AI workflow happen. And as a part of the open enterprise informatics platform vision, Philips IMS is already able to seamlessly integrate with the LIS, EMR, barcode systems using standards. And in addition, it will be equipped with a DICOM interface to exchange images with other DICOM actors to enable collaboration and data sharing across the health enterprise. Next, I would like to deep dive slightly on how, as Philips, we would like to retain the strong points of the platform while being flexible enough to adapt to the changes in oncology industry. I am often asked why our scanners want to work with iSyntax. And my question back is, why should the best format in the industry be changed to a less efficient version? So then how is iSyntax the best image format today? iSyntax requires 25% smaller file size for storing whole slide images. The wavelet transformation technology allows users to zoom and pan through the images quickly. It is a highly efficient format for multidimensional data and is ready for cloud storage. Unlike other formats, that have a limited dynamic range, the iSyntax pathology format supports deep color, including 30-bit and 48-bit with multiple color channels. And this was the first whole slide image format that obtained market access in the US. Next, I would like to quickly touch upon the newest release, the Pathology de-identifier. The DID is basically a tool you can put on the IMS to facilitate the selection and de-identified export of whole slide images created in the PIPs. It allows users to query the images available in the IMS by applying filters on the metadata attributes associated with the images and cases in IMS. It enables rapid export of 250 iSyntax images per hour, can be either manual one-time or automated based on your predefined rules. Cohort selection based on metadata, public tags, dates is possible. Users can customize what data should be de-identified and many, many more such features. I would like to conclude my time by saying that Philips is fully invested in making digital pathology a building block and hygiene factor to develop precision diagnosis and precision medicine a reality in the field of oncology, and thus playing our part in saving lives. Over to you, Stu, and apologies if I was too passionate to not keep track of time.
Perfectly on time there, Kieran. Yeah, so as Kieran has mentioned, you know, being able to go from digitizing the images all the way through to providing the open infrastructure to allow us to be able to deploy our AI has really allowed us to drive some great successes. I would like to now hand over to Dr. Judith Sandbank, who will talk about the journey that they have been on at Maccabi, and talk about their experiences with both digital and AI. So, Dr. Sandbank, over to you.
Thank you, Stuart. And hello, I'm Judith Sandbank, Head of Pathology at the Megalab Maccabi Healthcare Services. I'll let you know Maccabi a little bit. Maccabi is an integrated payer provider in Israel, taking care of nearly 2.5 million members. It has one of the world's largest digital data sets of nearly 30 years. It has a central pathology institute receiving over 200,000 histology cases and over 200,000 cytology cases annually. Of these, over 700 prostate and over 7,000 breast biopsies are received annually, with a 10% annual growth. We, like much of the rest of the world, are suffering of an acute shortage of pathologists, and for the above workload, we have only 10.5 full-time equivalents. I know it's written here 12, but the reality is 10.5. The very heavy workload may lead, of course, to both diagnostic errors and to prolonged turnaround times. Ibex partnered with Maccabi over 4 years ago, and this enabled Ibex to use all the data available in the electronic medical records, pathology reports, and of course in scanned pathology slides. Ibex trained the AI algorithms based on this data and on data from other pathology institutes as well. In order to achieve this, assuming that AI solutions can help pathologists meet the workload challenges, Ibex and Maccabi decided to test the clinical utility and accuracy for both the Galen prostate and the Galen breast for quality control. Slides were scanned at 40x using a Philips scanner in Telesight, and the AI second reads were performed on the whole slide images of prostate and breast. And now I can say that the algorithms that were developed and others that are on their way represent one of the most exciting revolutions that pathology has experienced. We are actually deploying AI in our routine practice, a clinically active, very active pathology department, in order to perform more accurate and more timely diagnoses. Both models are deployed as second read for several years, meaning that 100% of prostate and 100% of breast biopsies have a quality control check without having an impact on pathologists' time and our turnaround time. This, of course, creates confidence in the diagnosis for all involved. First of all, the patients, then the clinicians, and of course, the pathologists. This platform is of the highest clinical accuracy and is CE-IVD certified. In the past, we could not find time even to do the 10% quality control that is often done in pathology departments. Here you can see the workflow. The second read app runs automatically on all prostate and breast biopsies in parallel to the routine workflow and alerts on discrepancies, prompting a second targeted pathologist's review. The Galen prostate alerts either on a high cancer probability in a slide originally diagnosed as benign, or on a higher Gleason score in a slide or case diagnosed originally as a Gleason 3+3. The Galen breast alerts on invasive lesions diagnosed as in situ or benign, or on in situ lesions in cases diagnosed as benign. Both the breast and the prostate have been validated with extremely high performance, as you've seen already in Stuart's slides, but you can see it here again, with AUCs ranging from 0.994 to 0.998. The Galen prostate was demonstrated to have the highest accuracy in the field, with detection of multiple features in a study done at the University of Pittsburgh Medical Center. This was published last year in The Lancet. The deployment of the Galen prostate resulted in cancer alerts for around 8% of slides from over 230 cases diagnosed as benign by the pathologist, and as Gleason 7+ alerts for around 4% of slides diagnosed as Gleason 3+3. The alerts were focused on specific areas visualized by heat maps, resulting in minimal review time of around 1% of the pathologist's time, and resulting in several revised diagnoses, leading to changed management. And here are some examples of misdiagnoses caught by the Galen prostate. Here on your left is the first ever patient whose cancer was diagnosed by AI. You will see the cancer on top on the H&E slide with a dark red heat map indicating high probability for cancer, and indeed it was cancer, and the report was revised. On your right you can see an example of a G3+3 diagnosis revised after the second read to a G4+3. The Gleason heat map shows Gleason 3 in blue, Gleason 4 in greenish yellow, and G5 in red. The deployment of the Galen breast resulted in invasive cancer alerts for around 4% of the slides diagnosed as benign, and for 15% of slides diagnosed as DCIS. In situ alerts were raised for around 5% of cases diagnosed as benign. Some alerts, both for prostate, as I said before, and both for breast, led to revised diagnoses, which of course have clinical applications. Here too, the alerts are focused on specific areas associated with heat maps for infiltrating duct carcinoma, infiltrating lobular carcinoma, ductal carcinoma in situ, as well as other features such as angiolymphatic invasion, tumor infiltrating lymphocytes, etc. And here are examples of breast misdiagnoses that were identified. On the left is again the first ever invasive breast cancer detected by AI that revised the original diagnosis of a DCIS with a microinvasion. And on the right is a missed low-grade DCIS or ADH. So what does it look like for the pathologist using the Galen platform. Here's the interface, which provides a case list with summaries of the diagnoses and alerts. The interface is web-based and can be accessed anywhere through a browser. Clicking on the case opens up the list of slides within the case and the specific alerts. Clicking on the alert button automatically opens a view of the relevant heat map, as you see here. This is a cancer heat map for an invasive cancer. The viewer, by the way, is scanner agnostic, and when you click on a bar of the keyboard, you will see the H&E without the heat map, and this indeed is a cancer. And here, the next slide, you can see an alert for a Gleason 7+ detected in a case diagnosed as a Gleason 3+3. Clicking on this alert will bring us to the heat map of the slide with the Gleason heat map. The Gleason heat map is composed of 3 colors, of a G3 being blue, G4 being yellow, and G5 red. In this case, we have mainly yellow and blue. And in this case, we can also very easily see the amount of G3 compared to G4 and report it accordingly. Clicking on the bar will remove the heat map and we will see the H&E. This is another example, finally, just to show you the accuracy and sensitivity of the algorithm. This is an alert for a perineural invasion, which usually is minute and easy to miss, but not when you have AI to help you out. And here's the H&E of this slide, showing in the center the nerve with a tumor gland surrounding it. Examples for the Galen breast in general are as follows. Here we have an invasive cancer heat map. Removing it will show us the morphology. This indeed is an infiltrating carcinoma. In this case, it is an infiltrating lobular carcinoma. The algorithm, by the way, can differentiate easily between lobular and ductal carcinoma, between high-grade DCIS and low-grade DCIS, and so on. An example for the DCIS heat map. This looks to me like ET with burning eyes. Removing the heat map shows you the high-grade DCIS. And in the next slide, we can see a heat map for an ADH, for a low-grade in DCIS, probably more in ADH. Removing the heat map will show us the morphology. The AI, which was deployed for the last 3 years, was actually the mechanism through which we managed to persuade the management of the importance of digital pathology for our department. The business case of just turning digital is much less convincing than the digital platform plus the AI. Having AI is also easier to help the pathologists to move from the microscope to the screen. And I'm seeing it happen already as we speak. We chose the Philips scanner for the following reasons, and also for the rather good reason that we have a good experience with it for the last 4 years, because we were and are using it for scanning slides for teaching the models. The Philips scanner has an open platform. It has a high throughput, 300 slide capacity. It is really a walk-away system. The loading and unloading is very, very easy. And it has integration capabilities. What can we learn from digitization? We are just in the midst of it, so we still have a lot to learn. First of all, we know that one of the most important features is to have an open platform so that we can use AI, because we use AI today and we will be using it much more as we get along. While choosing a digital system, we have to evaluate its performance on how the pathologists can work with it and how it will be supported by AI. The slides must get a superb preparation, and this we have seen already and made the shift in the lab for receiving and performing superb slides so that the scanner can scan them easily without any difficulties. In summary, this, first of all, is a first ever AI-based multi-tissue diagnostic solution deployed in a routine clinical practice in pathology. Secondly, it was proven to be extremely useful for increasing diagnostic accuracy and safety, as we have now a very accurate 100% quality control system for both prostate and breast, and soon new tissues to come. And almost at last, the AI enabled us to make a strong business case for fully digitizing our department. We have now 6 high-throughput Philips scanners and about to get fully implemented. And last but not least, we are about to start using routinely the first read application for prostate in the coming few days, and are very excited about it. You will hear more about it from Dr. Delphine Raoux. There is no doubt that the equation, pathologist plus AI, is definitely better than the pathologist alone. And I'm sure we will enjoy it tremendously as we go along. Thank you for listening.
Great, thanks, Judith. Yeah, I'm always amazed to hear the work that you're all doing at Maccabi. Really great stuff. I'd like to transition now, and you already set it up, to some of the work that's being done in France by the team at Medipath. So without further ado, I hand over to you, Delphine, to give us an update on some of the work that you've been doing. So Dr. Delphine Raoux, over to you.
Thank you, Stuart, for the introduction. Hello, everybody. My name is Delphine Raoux. I'm a pathologist in charge of innovation at Medipath France. I am delighted to present the first large-scale study in which pathologists perform primary diagnosis with the support of an integrated artificial intelligence solution. The story of this study begins with these observations: the increase in cancer cases, the growing complexities in diagnosis, and the shortage of pathologists. In this context, Ibex Medical Analytics developed Galen Prostate, an AI-based diagnostic solution for prostate biopsies. Medipath is the largest network of pathology labs in France, diagnosing over 5,000 prostate biopsies per year, done by 100 pathologists over our 24 sites. We decided together to evaluate the utility of this AI solution and compared the performance of pathologists that use Galen Prostate for primary diagnosis to their performance using a microscope. The data include 480 consecutive cases from Medipath, meaning 3,628 slides, used in 3 study phases: a training phase, a pilot phase, which is an intermediate step for pathologists who had never worked digitally before, and the test phase. 8 pathologists from 6 different sites of Medipath participated to this study, made with 2 parallel arms and a crossover design. Diagnosis times were recorded each time from the beginning of the pathologist analysis to the end of the report. Major discrepancies were reviewed by 2 experts on prostate cancer, We establish the ground truth based on H&E slides and IHCs. Our objective was to compare the accuracy and efficiency in primary diagnosis of 320 all-comers prostate core needle biopsies, including 2,411 IHNC slides, using the AI-powered Galen prostate, compared with the use of microscope. Turnaround time and user experience were also evaluated. The accuracy performance of Galen prostate was demonstrated in multiple labs, as you said, Stuart, at the beginning of the webinar, such as Maccabi in Tel Aviv, Israel, where prostate and breast algorithm are used routinely now. The University of Pittsburgh, USA, where Professor Pantanovich published the results of their clinical validation and deployment study in The Lancet, and Medipath, France, where the validation study for CE mark was performed and presented at USCAP last January. You can see that the results of the performance are very homogeneous. The AI solution used in this study for primary diagnosis was developed as integrated AI-based diagnostic support application with case prioritization worklist, slide viewer, AI results, and reports. The solution also supports pre-ordering of IHCs and user quality control indicated the slide preparation issues. In order to increase efficiency, an automation of the workflow allows to provide many insights, such as AI case classification, cancer and Gleason heat maps, tumor length calculation, and important pathological findings, such as perineal invasion and high-grade PIN, and other insights integrated in the pathology report. The study shows that Galen prostate significantly improved diagnostic efficiency with reduction in diagnosis time compared to the microscope arm for both benign and cancer cases. For benign cases, diagnosis time in the AR arm was 32% shorter than on the microscope arm, and for cancer cases, diagnosis time in the AR arm was 25% shorter. The average reduction in diagnosis time on the AR arm compared to the microscope arm was 27%, which translates to a 37% gain in productivity. You can also note the significant improvement in diagnosis time between the study phases, demonstrating the pathologist's fast learning curve for working with AI. The accuracy level remained very high, despite the fact the pathologist worked fast. 15 slides had major discrepancies, with most of them were limited to small tumors. Regarding the AR arm, there was a 99.7% agreement rate between the pathologist and the AI classification. Here are examples of cancers that were missed by pathologists on the microscope arm, but detected by Galen prostate AI algorithm, as shown by cancer heat map. On the left, there's a small adenocarcinoma focus of Gleason 3+3 that was the only cancer slide in the entire case. On the right, there's a case of high-grade cancer with tumor length of 5 millimeters that was missed on the microscope. And here are examples of discrepancies on Gleason grading. Pathologists will acknowledge that grading can be difficult on certain borderline cases, and Galen prostate can offer some help. The misgraded cases diagnosed on the microscope arm were graded accurately and then corrected using Galen prostate after review by experts. On the left, you can see on Gleason 4+4 on the microscope arm, modified with Galen prostate to include Gleason pattern 5. On the right, another higher grade cancer was correctly diagnosed by the pathologist on the AR arm and confirmed after further review by specialists. Here are shown some of the features that were missed by pathologists with a microscope, but detected by pathologists with Galen prostate. On left, you can see a small focus of perineural invasion, and on the right, the detection of high-grade PIN in a first diagnosed benign case. Some additional examples. First, there is a slide that was overdiagnosed as cancer on microscope and was analyzed by the AI as benign, as was confirmed after further review by a specialist. On the right, some examples of the precise measurements of tissue and tumor length performed with the aid of the AI system. The AI solution was also useful in decreasing case turnaround time. The pre-ordering of IHCs based on AI classification enabled a single review for almost all cases. This contributed to a significant reduction in the average turnaround time required to diagnose a case from 1.8 days in the microscope arm to 9 minutes in the AR arm. We have also surveyed the participating pathologists to evaluate their user experience in working on the Galen prostate AI solution. The survey results show an extremely positive user experience. All the participating pathologists prefer to continue working with Galen prostate over the microscope. To conclude, this is the first large-scale study in which pathologists perform full primary diagnosis with the support of an integrated artificial intelligence-based solution. This study demonstrating that Galen prostate supports pathologists well during primary diagnosis with accurate detection of multiple clinical features such as cancer, Gleason, tumor size, and more. The use of AI classification, cancer heat maps, and other tools improve the diagnostic efficiencies with significant reduction in diagnosis time and productivity gains. Galen prostate demonstrated high accuracy level and concordance between the AI classification sorry. Sorry, and the ground truth. The study also shows that case turnaround time can be significantly reduced in routine practice by using artificial intelligence. Finally, the overall user experience was markedly better with Galen prostate than with the microscope. Since a year now, Medipath is using Galen prostate for second read over several labs in routine practice, helping pathologists improve daily diagnostic accuracy. We are going to start the deployment of a first read application of Galen prostate and also the Galen breast solution, recently CE marked. Sorry, I lost my voice. The digitalization of Medipath network is in progress with the installation of 3 scanners in 3 different labs. And AI is being the new tool in the practice of a pathologist for tomorrow. I would like to thank all the colleagues from Ibex and Medipath and all the experts that participate in the study. Thank you for listening, and sorry for my voice.
Great job, Delphine. I'll give you a moment to maybe take a sip of water, and before we come over to you with questions. So I'm seeing loads of questions that have come in. So I thank everyone for this. I already can see we're not going to be able to get to all of them, but let's have a go. Michelle, I see a question coming in from you that is targeted towards Dr. Sandbank. So the question here, Judith, how much time does using AI add to the overall diagnostic turnaround time? So a question to you, Judith.
Thanks for the question. AI today, the second read doesn't add much to the time spent on it. We really focus on the heat maps, go to them, and decide whether it's wrong or right and go on. We have not started yet with the first read. We're about to start, so I cannot give you the results so beautifully as Delphine has given. I hope we will have the same experience. For now, the second read does not prolong the time at all.
Great, thanks, thanks, Judith. I have a question here for you, Delphine, if you're able to take it. And there's with the fact that you've moved across the multiple labs and moving across the network. If you'd just like to comment if all pathologists that are working with the AI share the same feeling as you towards AI.
Yes, we have a lot of pathologists working in Medipath, and at the beginning, there's some pathologists are a little bit afraid with AI. They think that AI will replace pathologists. But now, with this study and our experience, they see that it's a real help, a real need for pathologists like IHC are at the beginning, and they are very pleased to use it now. Yeah.
Super, great. Then as I go through, I'm seeing quite a lot of questions that are asking about LIS and the level of integration there. So one of the things I'll do for all of those is I'll follow up separately. So we have quite some integration documents that that would be able to help there, and have also published an API to be able to go over those. I have just going through here. So there's a question here about how you see reports changing. So how could you consolidate radiology and pathology reports into one form or page? And then I see some other questions. So maybe Judith, if you want to take that one, how do you see pathology reports changing based on what AI can bring?
Well, they can change. Regrettably, we are not there yet because we're changing our LIS system. So we do not have the capability of integration as of now. But my dream is that we will get a full integration, as Delphine has described. Once the tissue is scanned and the algorithm is going over it, it will order special stains, IHCs or others. The slides will come to us, and the report will already be half ready, such as tumor lengths, tissue lengths, the slides, the stains that were ordered, the diagnosis, the Gleasons, and so on. And the only thing that will be left for us is to change parts of the report if they were not filled in correctly by the algorithm. The other thing is that an algorithm would be in charge of the sections of the biopsies coming in, and would put them in a scale of urgency. The more urgent ones to go on first, to go to the right doctors, to the right specialists, to the uropathologists, to the breast pathologists, to the brain pathologists, and so on, and make this much more efficient. So once we have this drive within our system, we will be quite efficient.
Super, thanks, thanks, Judith.
If I had just a little word about what Judith said, it's exactly the the case for first read application, we can already fill with the AI like all the report and just change when we don't agree with the AI or if AI cannot fill some points, and first read application make the report, and after it's communicate with the LIMS. So it's already done.
Super. There's another question coming in here from James. It says different labs use varying hematoxylin and eosin staining methods and reagents that can result in slightly different shades of staining. Do these changes affect the effectiveness of the AI? So I can comment on that one. So the answer there, James, is that the system is designed to be able to cope with that, particularly with a lot of the work that we've done in France. We see not only H&E, but H&E-S, so where safran is used. And the system does very well in these as well, as you would expect. And the reason for that is really the vast amounts of data that are brought in to design these models. So we heard about the large volumes of data that we have from Maccabi. We have these large volumes from many other sites as well. In total for the prostate model, well over 60,000 slides from around the world have been used to be able to drive that model. And of course, that incorporates different scanners, different staining protocols, different staining companies. And by having all of that data as part of that model, it means the algorithm is very robust. And that's a long-winded way, James, of saying that no, the different staining methods and reagents don't affect it. There's a question here that is coming in around scanners. So I don't know whether you want to take this one, Kieran. The question is around the 300 slides, and is this designed such that labs can run overnight, allowing 24/7 scanning?
Yeah, so the question I think there is that what is the throughput of the system and how many slides can you do in 24 hours? I think the answer to that question is that the system, when you say system, it comprises of the scanner and the IMS platform. Per scanner, if you say you can scan around 600 slides if you run a 24-hour cycle. But if you consider together with an IMS and add number of scanners to it, then a system, typical system can scan around 8.4K slides per day. So that's the maximum. So yeah, it depends a little bit on what combinations do you put.
Super, thank you. A question has come in from Michael. When can we expect FDA approval for Ibex? And then also how this relates to the billing. So yeah, there is no FDA approval for any AI yet. It's certainly something that we are working on, both as a company and also as an industry. One thing that we did announce just the week before last was that Ibex has been granted breakthrough device designation by the FDA, which will allow us a supported and accelerated path through that process. So yeah, rest assured, we're certainly working on that, and yeah, very much hope that we can update on that soon. I think with the time running out, we maybe have I see a couple more questions come in. Yeah, so there's so the last question, Kieran, maybe can come to you. So it's a question from Richard, and it's when is the likely release of the DID?
Well, the first few customers are already being deployed, and once we have feedback from those first customers, hopefully from the next month, we'll be able to roll it out to more customers.
Super. I then would like to take yeah, the last minute to just thank everyone for attending. Particular thanks to Delphine and to Judith for joining and sharing the journeys that they are on with implementing digital pathology and AI at their labs. My thanks also to Kieran for co-hosting this together with us. I think the combination of the open platform from Philips combined with the open approach towards implementing AI from Ibex is a really powerful tool the pathology labs can use, as I hope that you have seen from the two speakers today. So with that, I thank everyone for their time. If we haven't got to your questions, I promise to follow up with them via email. And I wish everyone a good remainder of the day. Thanks, everybody.